Okay, welcome back, guys. Today, welcome back. We are going to continue on the questions that we covered. So we're going to start with question number number five and stuff. So we're gonna continue with sorry. Welcome back, guys. Welcome back. So continuing with the previous lesson, we are um, going to do um, the midterm for ELC, and we're going to continue with the questions that we left. So let's just start with this question paper. ELC 2. Does anyone have any questions about the last question that we did, question number 4? Are there any questions? Does anyone have questions from the first class? Okay, let's do question number 5. Okay, um, let's solve this question. Let me just ask if you guys are able to see the screen. Let's see. Are you guys able to view the notepad that I just showed? Students, are you guys able to see the notepad? Mm, okay, let me just solve this question for you guys. So over here we have a circuit, right? So the question says determine the voltage drop across the 7 ohm resistor. So they want to know what is the voltage drop here. So in order for us to find the voltage, we have to first redraw the circuit. So let me just take this down here. So they want us to find the voltage over here. So I'm just going to redraw the circuit. So starting from this point, we are going to move from right to left. So we're going to move from right to left, right? So starting at this point, we have 8 and 11, right? after 8 and 11 we have to come down to this point, which then branches off, right? So at the from the 8 we come down, and then we have to branch off. So we have that one, and then we'll draw another branch. But we know that this branch and that branch connect, so we're gonna put a 7 here, and we're going to connect it with the 11, because the 7 is connected with the 11 as well as the 8. So we are done with this one. Let's now go here. So we have a 5, right? From there to there is a 5. And then we have a 9, between 5 and 7, we have a 9. So between 5 and 7, we have a 9. So let's draw the 9. So you can see this point and that point is the same as this point and that point. So after the 9, we're going down here. So we are done with this. So we are going down and we have a 12 volt. So we have, let's draw 12 volts, right? And then a we have a 2 here, and then it reconnects with the 9. So we have a 2, and it reconnects with the 9 volts there. Then these 2 points, as you can see, that these 2 points are parallel with this one. So we can draw the parallel of that circuit, which is the 8,5 ohms. Is there anyone who is lost or confused or who does not understand? Any questions on the redrawing the diagram? Do you guys have? Please start over. Okay, so someone is asking me to start over again. Sure. Okay, sorry for that. Let's go back to the notes and start again. Okay. Let's start from the beginning. Okay, so this is our question, right? And we have to be able to redraw this question, because the question wants us to determine the voltage across the 7 ohm resistor. So they want us to determine the voltage across the 7 ohm resistor, right? But first we need to redraw this diagram, and we're going to redraw the diagram. So we can see that number 8 and number 11 are in series. So let's start with the 8 and 11 are in series. Cool. After drawing 8 and 11, we see that this point and this point, right, between these 2 points, there's a 7 ohms, right? But it's parallel, so we're going to draw 7 here between 8 and 11. So then we see that 5 is in series with this circuit over here. So we're going to draw 5 in series. 5 in series, right? After drawing 5, we can see that these 2 points over here, it is in parallel with the 9, right? So we're going to draw the 9 over here. Okay, so we are moving from right to the left side, right? So let's get a different color. About red. Okay, so after that we draw a line, right? And we notice that this line, this point here and this point here, they are parallel with the 9. So we're going to draw parallel with the 9, this point and this point, right? Those 2 points over there. So we have a 12 volt and we have 2 ohms, right? After that, we're going to add the remaining value. Let's use yellow. So we see that this point, sorry, that is the remaining resistor, which we're going to draw over here. Is that clear? Do you understand what is happening? Or should I repeat again? Miss, I don't know. I can't pronounce your name, but can you just message in the group chat, in the chat, if you understood what is being done? Yes, okay, so you understand all of those things. Okay, so let me just erase this here. Delete. Okay, so the question wants us to get the voltage here. So we have the voltage, right, which is 12, right, 12 volts. But we need to find the resistors and we need to find the current. So To solve this question, right, we are going to first find the resistors. So step one is to find the resistors, and then step two would be to find the current and the voltages, and then find the voltage at 7. So the question wants us to find the voltage at 7. So V7 equals to, that is our question. Okay, so let's copy this over here. Copy. Let's paste it over here. Paste. Okay. So we're going to add the resistor here, right? So 8 plus 11. So 8 plus 11 gives us 19, right? So we know that 19 and 7 is parallel. So we're going to add those two. So we have 1 over 19 plus 1 over 7 to the power of minus 1. So that's the first one. Number 2. Okay. Let me just get a calculator. 1 over 19 plus 1 over 7 to the power of 1. So we have an answer of 0,195. Oh wait. Let's do this here. Resistor 1 is equal to 8 plus 11 equals 19. Then resistor 2 is equal to 5,115. So resistor 2 is equal to 5,115. So resistor 3, we can see that the 7 and the 5 are in series. So we have R2 plus 5, because R2 and 5 are in series, right? Um, all of this is R2, and all of that is R1. Okay, so we're going to find R3, which is equal to plus 5 equal to 10 comma 115. So this here is equal to R3 is equal to 10 comma 115. So next is going to be or 4, and or 4 is equal to, so on top we have or 3, and at the bottom we have 9. So then we have 1 over 10 comma 115 plus 1 over 9 minus 1. So or 4 is equal to, so this is parallel, this is series, and that's parallel. Okay, so R 4 is going to be 1 over 10.115 plus 1 over 9 to the power of minus 1 is equal to, so we have 4 comma 7 6 2. So R 4 is 4 comma 7 6 2. Okay, I think I made a mistake here, but anyways, you know, 8.5, that's 8.5. 8.5. Okay, so now we have all our values. So let's put that together. Okay. We have 4 comma, sorry, 4 comma 762. Then we have 12 and 2, and then we have 8 comma 5. Is there anyone that is lost or confused as to how we got this? If you want to play with the answer that we got. Okay, so continuing with the diagram, we're going to um, we see that this these two are in parallel, so we're going to add the two together. So we have R5 is equal to 1 over 4 comma 762 plus 1 over 8 comma 5 to the power of minus 1. So R5 is equal to 1 over 4 comma 762 plus 1 comma 7.5. So we have an answer of 3,052 ohms. So let's redraw that circuit. So we have 12 volts, 2 ohms, and 3 comma 052. All of them are in series. As you can see, we went from something that is complicated like this one and this one. This two is very complicated, but now we simplified it into this here, which is much more simplified and much easier to solve. So continuing with that, we are going to now um, find the current. So find the current. So we know, right, from Ohm's law that the voltage is equal to the current times the resistance, right? So the voltage is, so the current is equal to voltage over the resistance. So the voltage is 12 volts and the resistance is 2 plus 3.05. So it's going to be 12 over 5,052. And then we have a current of 2 12 over 5.052. So we have a current of 2,37 amps. So that is our current that is flowing. So I1 flowing through the circuit, right? So that there is our I1. So we use Ohm's law to find the current voltage over total current. So this is total voltage over total resistance to get total current. So moving now to the next page, we are going to have to find the voltage in each of the circuits, right? So like, sorry, um, remember that this is in series, right? But this one is is like a mix. It has a mixture of series and parallel, right? So what we're going to do is we're going to find the voltage at this point. What is the voltage at that point? So we have the current, right? And we have Ohm's law, which is voltage is equal to the current times the resistor. So to get the voltage, we're going to multiply the current by the resistor. So we have a current of 2,37 multiplied by the resistor, which is 3,052. So why are we using the 3,052 instead of the 2 ohm resistor? Is because we are trying to find the voltage at 7. So we are moving away from the 2. So moving away from 2, we're going to use um, the resistor, which is 3,052, 3,052, and we're gonna get an answer of 2.37 multiplied by 3.052. We get an answer of 7,28 volts. So that is our volts, right? So coming to our diagram, so remember that this is actually representing this circuit here. So therefore, the voltage here is equal to 3,052, and the voltage here above is also equal to 3,052. Remember that
um,
um,
in
in
series the
series the
current is
current is
equal.
equal.
So in
So in
series
series
I1
I1
year
year
and
and
I1 year
I1 year
is the
is the
same.
same.
They all
They all
equal.
equal.
But
But
in
in
parallel
parallel
circuit, we
circuits, we
know that
know that
the
the
voltage
voltage
remains the
remains the
same.
same.
V1
V1
equals to
equals to
V2.
V2.
So
So
now
now
we are
we are
going to
going to
move
move
away
away
from the
from the
8
8,
comma
comma
5.
5.
So we're
So
going
we're
to
going
move
to
away
move
from the
away
8
from the
comma
8, comma
5.
5.
And
And
now
now
we are
we are
moving
moving
towards.
towards.
So
So
we are
we are
away from
away
this,
from this,
away from
away from
this.
this.
We are
We are
currently
currently
over
over
here.
here.
These two
These two
circuits, right?
circuits, right?
So we
So
know
we know
that the
that the
voltage
voltage
here by
here
the
by the
9
9
and by the
and by the
5
5
is
is
going to
going to
be
be
the
the
same
same
the
the
same
same
voltage,
voltage,
right?
right?
So the
So the
voltage
voltage,
what is the
what is the
voltage?
voltage?
3
3
3
3
comma
comma
052.
052.
Is that how
Is
much
that
we
how
got?
much we got?
3
3,
no,
no,
7
7
comma
comma
28.
28.
Sorry,
Sorry,
7
7
comma
comma
28.
28.
7
7
comma
comma
28.
28.
That's the
That's the
voltage that
voltage
we
that we
calculated
calculated
here
here, right?
for
For
parallel,
parallel,
right?
right?
So
So
moving
moving
on
on
here, we
here,
see
we see
that
that
this
this
is
is
also
also
voltage
voltage
7
7
comma
comma
28.
28.
Voltage
Voltage
equals
equals
7
7
comma
comma
228,
228,
right?
right?
Because
Because
they're in
they're in
parallel.
parallel.
So
So
remember
remember
that
that
R3 is
R3
equal
is equal
to
to
10
10
comma
comma
10
10
comma
comma
115.
115.
So the
So the
voltage
voltage
here is
here is
equal
equal
to
to
7
7
comma
comma
28.
28.
But
But
remember
remember
that
that
this
this
is in
is in
series with
series
this
with this
one.
one.
So there's
So there's
going to be
going
a
to be a
voltage
voltage
drop
drop
over
over
here.
here.
There's a
There's a
drop in
drop in
voltage over
voltage
here
over here
because
because
it's in
it's in
series,
series,
right?
right?
So
So
because all
because
that
all that
voltage
voltage
drop,
drop,
we're
we're
going to
going to
find
find
a
a
current
current
over
over
there.
there.
So
So
let's
let's
copy this
copy
here
this here
quickly.
quickly.
Copy.
Copy.
So
Okay,
we
so
have
we have
this
this
question over
question over
here.
here, right?
So
So
we
we
have to
have to
find
find
the
the
current
current
that's
that's
moving
moving
through
through
here.
here.
We need to
We need to
find the
find the
current
current
that's
that's
moving
moving
through
through
this
this
these
these
points here,
points
right?
here, right?
Because we
Because we
know that
know
the
that the
voltage
voltage
is
is
equal
equal
in
in
parallel,
parallel,
but
but
in
in
series the
series the
current is
current is
equal.
equal.
So
So
we're going
we're
to
going
find
to
the
find the
voltage.
voltage.
We're going
We're
to find
going
the
to find the
current. So we
current.
know
So we
the
know the
voltage
voltage
equals
is
to
equal to
7
7
comma
comma 2
28.
8.
That's the
That's the
voltage, right?
voltage, right?
Then we
Then we
have
have
5
5
ohms,
ohms,
and
and
we have
we have
R2,
R2,
which
which
is
is
5
5
comma
comma
115.
115.
So there's a
So there's a
voltage
voltage
drop
drop
here,
here
and there's a
and there's a
voltage
voltage
drop
drop
here,
here,
right?
right?
So
So
let's
let's
find the
find the
current.
current.
So what
So
is the
what is the
current
current
over
over
there?
there?
Did we
Did we
calculate the
calculate
current?
the current? No.
So
So
let's
let's
find the
find the
current,
current,
and
and we know
we know that voltage is
voltage is
equal
equal
to
to
current
current
times
times
resistor, right?
resistor, right?
So
So
we're going
we're
to have
going to
to
have to
find
find
the
the
current.
current.
So the
So the
current
current
is
is
equal
equal
to the
to the
voltage
voltage
over
over
the
the
resistor.
resistor.
So our
So our
voltage is
voltage
how
is
much?
how much?
7
7
comma
comma
28,
28.
and our
And our
resistor
resistor
in
in
the
the upper
upper region is
region
how
is
much?
how much?
It is
It is
10
10
comma
comma
115.
115.
This one
This
here.
one here.
10
10,
comma 115.
115.
So our
So our
current
current
now
now
is
is
equal
equal
to
to
7.24
7.24
over
over
10.11
10.11
equals
equals
to
to
0 comma
0.716.
716. So the
So the
current
current
year
year
is
is
equal. We
equal.
know
We
that the
know that the
current is
current is
equal, right?
equal, right?
So we
So
know
we
that the
know
current is 0 comma 716,
that the
but we
current is
want
0,
the voltage.
716, but
So
we want the
the voltage
voltage.
is equal
So
to
the voltage is equal to
current times
current times
resistor.
resistor.
Our current
Our
is
current
0
is
comma
0, 716
716 multiplied
multiplied
by
by
our
our
resistor,
resistor,
which is
which is
5
5,
comma
51,
5.115,
5115,
and we
and
get
we
an
get an
answer
answer
of
of
0
0,
comma 716
716
multiplied
multiplied
by
by
5
5,
comma 815.
815.
So answer
Answer
there would
there
be
would be
0
0,
comma 716
multiplied by 5, 815
is equal
is equal
to,
to,
so we
so we
have
have
an
an
answer
answer
of
of
4 comma 16
4,16 volts.
volts. So
So
our
our
volts
volt
here
here
is
is
equal to
equal to
4 comma 16,
4,16,
and the
and the
volt here
volt
is
here is
equal to
equal to
4 comma 16.
4,16.
So
So our
our answer
answer
is
is
going to
going to
be
be
4 comma
4,16.
16. 5 comma 115,
115,
5
5,
comma 115.
115.
Sorry,
Sorry,
this
this
is
is
3,66
3,66
volts.
volts.
So
So
then
then
our
our
volts
volts
over
over
here is
here is
going to
going to
be
be
3,66
3,66
volts.
volts.
And
And
that should
that should
be the
be
end
the
of
end
the
of the
question.
question.
Do you
Do
guys
you
have
guys
any
have any
questions
questions
that
that
you would
you
like
would
to be
like to be
answered?
answered?
Are there
Are
any
there any
questions?
questions?
Do you
Do
guys
you guys
understand
understand
what
what
is
is
happening or
happening
what
or what
needs to be
needs to be
done
done in
in able for
able
you
for
to
you to
solve
solve thus
this
this
question?
question?
Okay,
Okay,
let's
let's
move
move
on
on
to the
to the
next
next
question in
question
the
in the
past
past
paper.
paper.
Have you
Have you
guys
guys
done
done
capacitors?
capacitors?
Students, have you
Students,
guys
have you
done
guys done
capacitors?
capacitors?
Yeah,
Okay,
Okay,
so
so
I
I
think
think
we
we
should
should
do
do
this
this
one,
one,
and
and
then we
then
can
we can
do the
do the
next two
next two
questions
questions
in
in
the
the in the next class that we have.
So
So
let's
let's
do
do
capacitors
capacitors
since we
since we
already
already
did
did
resistors.
resistors.
Capacitors
Capacitors
are
are
like
like
it's
it's
it's like the
like the
opposite
opposite
of
of
resistors.
resistors,
Whereas the
whereas the
resistors
resistors
they
they
normally
normally
resist
resist
the
the
flow
flow
of
of
current.
current.
Capacitors
Capacitors
actually
actually
help
help
assist
assist
the flow
the
of
flow of
current.
current.
So
So
they are
they are
basically
basically
like
like
batteries,
batteries,
right?
right?
But
But
capacitors
capacitors
have
have
like
like
a
a
slower
slower
discharge.
discharge,
So
so
they are
they
not
are not
restricting
restricting
the
the
flow
flow
like a
like a
resistor.
resistor.
So a
So a
resistor
resistor
will
will
resist
resist
the
the
flow of
flow of
current,
current,
and the
and the
capacitor
capacitor
will
will
assist
assist
the
the
flow of
flow of
current.
current.
So
So
the
the
only
only
difference
difference
is
is
that
that
with
with
capacitors
capacitors
the
the
is that
is that
the
the
formulas
formulas
are
are
basically the
basically the
same,
same,
but the
but
only
the only
difference is
difference
that
is that
you are
you are
going
going
to
to
um,
um,
you're going
you're
to
going to
change the
change the
formulas.
formulas in
It's going
it's
to
going to
change.
change
Like
like
okay,
okay,
we'll do
we'll
this
do this
question and
question
you'll
and
see
you'll
that
see that
they
they
use the
use the
same
same
formulas
formulas
as
as
um,
um,
series and
series and
parallel,
parallel,
but
but
they are
they are
used
used
differently.
differently.
So let's
So let's
copy this
copy this
thing.
thing.
Copy,
Copy,
copy.
copy. Let's put it on.
Let me just
Let me
copy
just
this
copy this
question.
question. I don't know why this question doesn't want to copy.
Let me
Let
just
me
do a
just do a
screenshot.
screenshot of this thing.
Sorry about
Sorry
that.
about that.
Let me
Let
just
me
copy
just
this
copy this
question again.
question
I don't
again. I
know
don't know
why
why
it's not
it's not
copying.
copying.
Okay,
Okay,
there
so
is
there
the
is the
question.
question.
So
So
for
for
this
this
question,
question,
question
question
8,
8,
what
what
does
does
a
a
capacitor
capacitor
do?
do?
So that
So
is
that
like
is like
the first
the first
question.
question.
I
I
think
think
like
like
you
you
might
might
have,
have,
I'm not sure
I'm
you
not
have
sure
the
you have the
same
same
lecturer
lecturer
as
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 me,
me,
but
but
normally we
normally
would
we would
have
have
definitions as
definitions as
well.
well.
So
So
um,
um,
I would
I would
advise
advise
that
that
you
you
firstly
firstly
go
go
over
over
definitions.
definitions.
So
So
I am
I am
searching for
searching
the
for the
definition
definition
of this
of this
question, and
question,
it
and it
says
says
um,
um,
a
a
capacitor
capacitor
absorbs
absorbs
energy
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 under
under the
specific
specific
conditions
conditions
and
and
at
at
a
a
later
later
stage.
stage. The
This energy
energy
becomes
becomes
available
available
at
at
short
short
notice.
notice.
So
So
that
that
is
is
the
the
definition
definition
of
of
a
a
capacitor.
capacitor. Um,
I hope you
I hope you
guys
guys
took
took
down the
down the
definition
definition
because I'm
because I'm
about to
about to
erase the
erase the
definition.
definition.
It's
It's
okay.
okay.
So
So
like I
like I
said, right,
said, right,
that
that
the
the
capacitors
capacitors
are
are
similar
similar
to
to
resistors,
resistors,
but the
but the
only
only
difference
difference
is
is
that
that
the only
the only
difference
difference
is that
is that
you're
you're
going to
going to
see that
see that
wait,
wait,
let
let
me
me just
just
keep this
keep this
thing
thing here.
here.
Just
I
want
just
to make
want to
this
make this
a
a
bit
bit
bigger.
bigger.
Okay,
Okay,
so like I
so like
said
I
that
said that
capacitors
capacitors
are
are
similar
similar
to
to
resistors,
resistors,
but you're
but
going
you're
to have
going
to
to
make
have
a
to
few
make a few
changes.
changes.
So
So
over
over
here
here
we
we
have
have
capacitors
capacitors
in
in
parallel,
parallel,
but
but
we're
we're
going to
going to
add
add
the
the
capacitors.
capacitors.
So
So
12
12
plus
plus
3 is
3
equal
is
to
equal to
15
15
microfarads.
microfarads.
That's going to
That's gonna
be
be
over
over
here
year
15,
15,
right?
right?
And
And
then
then
these
these
ones,
ones,
they are
they are
in
in
series,
series,
but
but
we are not
we are
going
not
to
going to
add them
add them
like
like
resistors.
resistors.
So
So
let's do
let's do
this.
this.
So that's
So
one,
that's
right?
one, right?
Second
Second
one,
one,
it's
it's
1
1
over
over
15
15
plus
plus
1
1
over
over
4
4
plus
plus
1
1
over
over
9
9
to the
to the
power
power
of
of
minus 1
minus 1
is equal
is
to
equal to
resistor.
resistor. So that's gonna be 1 over 1 over 15 plus 1 over 4 plus 1 over 9 to the power of negative 1. So we have a resistor here of, so let's do this. We have resistor here of 15 and we have resistor here of 2 comma 3 3 7. And now you can see that 2 comma 3 is parallel with the 5. So let me just clear this up. So what we have is we have 2 comma 3 is parallel with the 5. So these are capacitors and basically we're just going to add it. So number 3 is 5 plus 2 comma 3, which is equal to also plus 5 equal to 7 comma 337. So number 3 R is equal to 7 comma 33 microfarads. So we have the 15, that's 15. We have 2 comma 3 and we have 7 comma 3, 7 comma 4. So now we see that, let's move this a bit down. We see that the 7 comma 3 4 and the 7, they are in series with each other. So for capacitors, when they are in series, we're going to do the um, opposite to what we did for resistors. So it's going to be 1 over 7 comma 3 4 plus 1 over 7, 1 over 7. 7 over here is in series with the 7 comma 3 4. So that's probably 1 over 7 comma 3 4 plus 1 over 7 to the power of minus 1. R is equal to 1 1 over 1 over 7.34 plus 1 over 7 to the power of minus 1 equal to 3 comma 58 microfarads. Is anyone confused or lost or need me to repeat myself? No? That's good. Okay. So what does the question one say? Question A says total capacitors. So we have found the total capacitor. Total capacitor. So this here is equal to the total 3,58. 3,58 microfarads. Okay. So with reference to figure 8, the charge on the 9 microfarads capacitor is 46 microcoulombs. So they are saying that the charge over here is equal, the charge over here, through the charge. So saying the charge over here, charge is equal to 46 microcoulombs. So this question says the charge on the 7 microfarad capacitor. So they want us to find the charge over here. So what we're going to do is add another page, copy this down. So we're going to do number B. They want the charge on the 7 capacitor. So what needs to be done is we need to go and okay, so we need to know that Q is similar to current, right? And we know that current is equal in like series, right? So the we're going to start sorry. So we're given the charge over here, right? Coulombs, right? How much coulombs? 46, right? So we have 9 microfarads capacitor and a charge of 46 microcoulombs. So we have these two values. So we know from our triangle that charge is equal to capacitor times the voltage. So our voltage is equal to capacitor over, no, it's equal to charge over the capacitor, which is equal to 46 microcoulombs over 9 microfarads. So we're going to cancel that, and we're going to have a voltage of, so 46 over 9, we're going to have a voltage of 5 comma 1 5 comma 1 watt volts. Wait, sorry guys, I made a mistake here. So they say that the charge on the 9 microfarad capacitor is um 4 comma 446, right? So we actually need to start with this whole diagram over here.
Sorry about the what happened earlier, guys, but I was my PC switched off and I was using my PC to record the session. So what I'll do is I'll finish question B. Question B is that they want us to find the charge on the 7 microfarads capacitor. They want us to find so we ended off here, right, where these values are given, right? Sorry, the charge and the 9 microfarads and the 7. So we calculated the voltage, which we got was 19,4, right, for the voltage in this, sorry, above here. So the voltage, so the current is 46 microcoulombs, this is farads, and then the voltage is 90,4 4. So after doing the voltage for the top one, we need to find a charge at the bottom one. So we need to find a charge here. So we know that for parallel circuits the voltage is the same. So the voltage is going to equal to 19 comma 4, right? And we have a charge, a capacitor of 5 microfarads. So our charge is going to be capacitor times the voltage, which is equal to 5 times 19,4 times 10 to the minus 6 for micro equal to, so we're going to have 19.4 times 10 to the power minus 6 times by 5 equals to, so we have 97 micro, Q is coulombs, so Q is equal to 97 coulombs, 97 micro coulombs. So now they want us to find the charge on 7. So the charge on 7 is going to equal to charge plus the charge. So we're going to add the two charges. We're going to add the 46 plus the 97, and then the total charge is going to be 46 plus 97 equals to 143 microcoulombs. So Q1, Q2, Q3. So Q3 is equal to Q1 plus Q2. So that is that question B. So now we'll be doing question number C. The supply potential difference. They want the potential difference for 1 mark. So they want potential difference. Potential difference, which is the volts, right? So the potential difference is equal to, we know that Q is equal to Vc, right? So V is equal to Q over C, which is equal to the total Q over the total charge, which is total Q is 473 microcoulombs over total charge, which we did over here, is 3,58 microfarads. Micro cancelled, so we have 143 over 3.58 equals to V total is equal to 39,94 volts. So the last question is energy stored in the 7 microfarad capacitor. So they want us to calculate the energy stored, D, energy stored. So energy, the equation for energy is equal to a half CV squared. And C is the capacitor, V is the voltage. So we're going to do half. So they want us to get 7 microfarads. The question says energy stored in the 7 microfarad capacitor. So a half 7 times 10 to the minus 6 multiplied by the voltage. What was the voltage on the 7 microfarads? 40. I think it's the 40 squared. So the energy is equal to a half multiplied by 7 times 10 to the power minus 3 times 40 squared equals to. Wait, we need to calculate the voltage. Did we calculate the voltage? Okay, wait. The Q C V is equal to Q over C, which is equal to 143 over 7. 143 over 7 equals to 20,42. 20,42. So our answer is now 0.5 times 7 times 10 to the power minus 6 times 20.42 squared equals to. So we have 1,46 times 10 to the minus 3 joules. And there you have it. We are done with capacitors. That is those are the solutions for capacitors, and I hope you enjoyed the recordings. I'll send this recording in a group for those that attended. Thank you and good luck with your exams.